if you're wondering why this is saying, these are essentially going to be the same thing using the product law or using positive exponents. If you use the product law, all that says is that if you have two powers that are the same, have the same base, 5 to the 8th times 5 to the negative 3, the product rule or product law says you can just add the exponents. 8 plus negative 3, right? So in other words, that's 5 to the 5. You could multiply it out, but we just are interested in how you can start to simplify it. Right? It says if you're multiplying powers, add the exponents, right? That's what that means. Multiply powers. Oops. Okay? Multiply powers, add exponents, right? That's what that product rule says. But now that you hopefully have the meaning of a negative exponent, you could also do it a different way if you wanted to, right? You could approach it and say, if you have 5 to the 8th times 5 to the negative 3, what I really want you to get is that multiplying by a negative exponent is the same as doing what here? Instead of multiplying by a negative exponent, you could divide by positive exponent, right? You could put that on the bottom like that. You could divide by 5 to the 3. Okay? 5 to the 8th times 5 to the negative 3, dividing by that negative exponent. Timesing by that negative exponent is the same as dividing by that positive exponent. Because then you can use the quotient rule, right? The quotient rule says, what's that equal to? 5 to the, if you got 5 to the 8 divided by 5 to the 3, it's 5 to the 8 minus 3. Or in other words, 5 to the 5. I mean, of course, it's going to be the same number. Right? Now I used up all my space for the next question, but that is because I am writing so big on here. But I can also do this. Does that make sense? This is now using the quotient rule, right? Write it using a positive exponent. Divide by positive power instead. And then use the quotient rule. I don't care if you know the names of the rules like quotient rule, power rule, all that kind of stuff, but essentially it's the same thing, right? Adding negative 3 is like subtracting 3. The other ones that are here, similar idea. This one's actually got both of them negative exponents. So you could either just right away add the exponents, right? So you could say that if you have 0.8 to the negative 2 and you're multiplying by 0.8 to the negative 4, you could just right away write 0.8 to the negative 6, and you could write that now with a positive exponent. 0.8 to the negative 6 is the same as 1 over 0.8 to the positive 6. That's as far as we're going to go with it. Obviously, you could evaluate that with a calculator and put it in there. This third one down here, x to the 5th divided by x to the negative 3. It follows again here that if you are multiplying by a negative power, it's the same as dividing by a positive power. It follows now that if you're dividing by a negative power, what's that going to be the same as? What's that the same as? If you're dividing by a negative power, you know in grade 8 when you learn to divide fractions, 8 divided by 1/3, or if you had 8 divided by 3/5, what were each of those things equal to? 8 divided by 3/5 was the same as 8 times 5/3, right? Dividing by something, multiplying by its reciprocal. This is the same thing. If you're dividing by a negative power already, that's going to be the same as multiplying by what? Multiplying by x to the 3, right? You can just make it x to the 3. If you have this x to the negative 3 on the bottom, it's like you could put it up on top and make it positive, right? There's nothing left on the bottom. It's just a 1. You don't need to put it there. If you have a negative power on the bottom of the fraction, you can put it up on top. If you have a negative power on the top of a fraction, you can put it down on the bottom, as long as you change the sign of the exponent. Because then if you say x to the 5th times x to the 3rd, it's just x to the 8th. So that would actually be method 2 here. Right, whoops. Let's try again. That would actually be this, right? Use positive exponents. Dividing by that's the same as that. Or you could just subtract, right? If you do this and subtract these exponents, x to the 5 take away -3. I think it's better sometimes to make them positive exponents first, so you avoid mistakes. It's got to be x to the 8th either way you do it. This one here, does that 3, the last one, does it apply to the x or the 2 or both of the things? If you have these brackets around it here, it applies to both. You need to make sure you keep those brackets there when you write it out. Otherwise, you can't write that as 2x to the 3rd like that. You got to keep the brackets there. Otherwise, this means something different than this. So just write it carefully. We're not going to actually evaluate it the whole way, but you can do it 2 different ways. Quotient rule, the bases are the same, even though there's 2 things in there, a 2 and an x. You could just write it right away and say 2x to the 3 take away -2. 2x to the, that's 5, right? You could actually work it out if you really wanted to, but you can't write it as 2x to the 5. It doesn't mean the same thing. If you want to use positive exponents, the same as the previous one here, 2x to the 3 divided by 2x to the -2 is the same as 2x to the 3 times that thing with a positive exponent, 2x to the 2. If you have a negative exponent on the bottom, you can move it up to the top, multiply, as long as you make it a positive exponent. So you get the same thing both ways, right? 2x to the 5. You could work it out. If you want to, you learned before that if you actually want to work it out where you get rid of the brackets, if it's in brackets like that, 2x to the 5th, it's actually 2 to the 5th, and x to the 5th, it's actually 32x to the 5th, but it's okay if you just stop there, that's fine. There's a your turn question for you to try that's very similar, and of course the answers are there, but just make sure you understand for yourself. The other one involves some of the other rules, powers of powers. I'm not going to do all of these here for you, but it's the same thing. Think about what the meaning of the negative exponents are, but you can still use power rules first. There's lots of other power rules involved there. There's the power rule where you have, remember you have to change this to a 4 here. We were changing that. There's power of a power. Power of something where it's a fraction inside. Power of something where you got 2 things inside the brackets there. Same thing with this. Powers of powers, and there's more than one thing inside the brackets. Follow along in the textbook. Ask questions. If you've tried, some of you have tried this last question here too, and it isn't completely directly related to negative exponents, but it is related to exponents and exponent laws. You just have to make sure you read the words here too. If you want to write a rate here for these things, see how they write the rate for grasshoppers per square kilometer. You need grasshoppers per kilometer squared. The thing that people are having trouble with is this your turn, because you got to notice this is in square kilometers, but over here it gives you the density ratings in square meter. You got to convert square kilometers to square meters. Square kilometers, square meters. If you have 1 square kilometer, let's say that's a square kilometer. If it's 1 square kilometer, 1 kilometer times 1 kilometer, 1 square kilometer. But a kilometer is 1,000 meters. If I make a square that's 1,000 meters by 1,000 meters, does that mean this is 1,000 square meters? Is a square kilometer 1,000 square meters? It's not, right? It's 1,000 meters times 1,000 meters. It's 1,000 meters squared. If you want to figure out how much this is, 1 kilometer squared, 1,000 meters squared, it's actually 1,000,000. And if you don't like writing out those numbers, it's actually 1,000,000 square meters. Or you could write that as 10 to the 6th. Write this using powers and see what you do. Okay? Anyways, can you get going on or get going on finishing that section. Asking for help if you need to.